Okay, so we have two equations here. Asking you to solve them. First one I should be able to solve. It's solvable by the techniques that you know. Second equation is not solvable by the techniques that we've learned, although I want you to give it a try so you see why it's not solvable. Then we'll talk about the easy way to solve it. As you're seeing, the first equation is easy to solve if you just remember to multiply both sides by x. And you really should do that at the beginning. Although if you do a couple of steps and still have that x in the denominator, still allowed to multiply both sides by x. As long as your steps were valid, which they were, you're going to get it. Okay. But I recommend that you just have a reflex. Get rid of denominators. The equation becomes very simple once you get rid of denominators, and they don't have to sit there distracting you or making things more difficult, or causing you to want to deal with fractions. You might have a fraction at the end, but you don't have to deal with it until the very end. So just to illustrate, we have, let's say we have 6 over x plus 9 equals 12. Okay, that's perfectly okay to subtract 9 from both sides. It's a valid step. And then you end up with 6 over x equals 3. Then you need to multiply both sides by x. Just do it at the beginning. It works either way, but again, if we just have the habit of looking for denominators and getting rid of them at the very beginning, life is generally a whole lot simpler, or at least it's no more complicated. Okay, so we multiply by x. And I'll do x over 1 just to emphasize. Okay. And we're going to get x over 1 times 6 over x. I'm just going to put everything over 1 since we're dealing with fractional expressions or fractional expressions. Okay. Now we know that we can rearrange this as x over x times 6 over 1, because the product of the numerators and the product of the denominators will be the same after we rearrange it. And x over x gives us 1, so we're just going to end up with 6 multiplied and divided by 1. That just gives us 6. So I'm going to put 3 dots there for those steps. And x over 1 times 9 over 1 is 9x over 1. And dividing by 1 gives you 9x. And similarly, x over 1 times 12 over 1 gives you 12x. Okay, so what do we do now? Well, you have options. You could subtract 12x from both sides because you know you're going to want all your x's over here. But usually you look at constants on this side and get rid of them. Then if there happen to be x's over here, you deal with it. That's a matter of style and taste, and either way you do it is okay. Well, we get 9x equals 12x minus 6. And darn, there's an x over here. Okay. And what you do there, you want all your x's on this side. So you do 9x minus 12x equals 12x minus 6 minus 12x. 12x minus 12x is 0. So we're going to get negative 6 here, and we're going to get negative 3x over here. And now what do? We simply divide both sides by 3, negative 3. And a couple of dots there. Rearrange that as negative 3 over 3 times x over 1, which is identical. and the negative 3 over 3 is equal to 1. So x equals 2. And we can plug that back in and check. 6 over 2 is 3. 3 and 9 is 12. You can check that one in your head pretty easily. Since x happens to, well, it's going to be, well, it's not always going to be a whole number or an integer. Okay. But when it's an integer that divides into 6, it's really easy to check. And if you got to write out a few steps, okay. In this case, the check is okay. Okay, nothing big about that, except again, I keep reminding people to multiply by denominators. Multiply by a least common denominator is the easiest way, but as long as you multiply by all the denominators, it's going to work. If you use the least common denominator, it's going to be less complicated. Okay. Now let's go to this, because this is really what we want to talk about, the kind of equation you get here, because it's the same equation, an x over here. So you're going to have 6 over x plus 9 equals 12x. And that's going to change some things. It's going to make it impossible to solve it as a linear equation because it's no longer going to be a linear equation. And you see why if you multiply both sides by x. Okay. And I'm not going to go through all the detail over here of doing the over what and all that stuff, but you want to think it. So x times 6 over x is going to be 6. X times 9 is 9x, of course, for the same reasons as we got down here. The only difference is we have an x times 12x, which gives us a 12x squared. Now we're in trouble. I won't say we're in big trouble because there's a really easy way to solve this. If you don't think you've got a factor, okay? Because you're going to end up with something you maybe wouldn't want to try to factor, but you're not going to be able to in this case. In most cases, when an equation like this comes up, it's not going to be factored. You wouldn't know that from the kind of problem sets you get in, of course, like this or pre-calculus, because a lot of them are factorable, but it almost never happens in the real world. Still, it's important to understand what happens when it's factorable so you get a better understanding of what happens when you use the formula I'm going to give you. Okay, well, unlike in the other case, we see that this is we want to immediately recognize that this is important, but kind of emphasize it. We've got x and x squared terms, and plus a constant term. That makes the equation quadratic. So we can't solve a quadratic equation as a linear equation unless we violate laws of exponents and stuff. And when people first see an equation like this, that's what they do. They do all kinds of crazy things that don't follow the rules of mathematics, things that violate the need to keep the expressions equivalent. Okay, they get rid of exponents. They just say, oh, that's an x squared. We'll just make that an x. Now I can solve it. Okay. Or they'll add the 2 to the 12 and make it 14x or something like that. Okay, because when you're desperate, you try anything. So we don't want you to be desperate. So we want, first of all, to recognize when an equation is quadratic. And for right now, that means you got some constant term, some x term, and some x squared term. Okay. So standard form of a quadratic equation. Okay. There's your standard form. So what I want you to do is take this equation or the equation that you got. Okay, use your own equation. Put the equation into the standard form. Put the equation 6 plus 9x equals 12x squared. Into standard form. Now, if you don't have your equation into this form here, if you didn't multiply through by x, either do it quickly or just go ahead and use my form. Okay. But you have kind of more ownership of your own equation. So if you use your own equation, it might stick with you a little better. Really doesn't matter very much though. Okay, so we subtract 12x squared from both sides. Right. So we got 6 plus 9x minus 12x squared equals 12x squared minus 12x squared. You know, we'll skip this step because if we do, we might accidentally move that 12x squared over here without changing its sign. Okay. And the rule isn't when you move this over, you change its sign. The rule is you add, subtract, multiply, or divide both sides by the same thing. Okay. Okay. So when we do this, of course, that's what's going to give us 0 on this side. And now I'm going to put this in order from largest to smallest exponent. Because that's the order this one's written in. Okay. Now, really what it comes down to, it doesn't matter what order you write it in. What this says is that A is whatever number you put in front of x squared, B is whatever number's in front of x, and C is whatever number doesn't have an x on it. Okay. That's really what the rule says. So if I mix the order of these up, it doesn't change the solution of the equation. When I put an x in and do this and this and this and then add them, it doesn't matter in what order I added them, so they could appear in any order. Okay, well, now the question is, I told you put this in the standard form. What good does that do? Okay, you're used to having the x's on one side and the numbers on the other side. What in the world do I think I'm doing here? Later on, we haven't talked about factoring yet. Okay. But later on, we'll say, well, maybe this will factor. Okay. Maybe this one really will, but I don't think so. Unlike, as I said, the factors, there's an easy way to solve. But if it doesn't factor, there's an easy way to solve it. Okay. You can always solve it. Even if it does factor, but you just don't see how. You can always solve it. Now, sometimes your solution will be, well, there's no solution. No real number solution. Okay, that's a possibility. If I randomly generate quadratic equations, just put random numbers in front of here, well, random numbers for A, B, and C, half of them won't be solvable. Here's a rule. I did that yet, but B first because it's the next letter I'm going to write, but it's not the first letter I want to write. I want to write X there because I'm trying to solve the thing. Okay. X equals negative B plus or minus the square root of quantity b squared minus 4ac, all that divided by 2a. Okay. Now, what this says is that if x is one of these two numbers, of course, these two numbers could be the same number if that square root happens to, if the b squared minus 4ac happens to be 0, then you only get one number because adding 0, subtracting 0, you still get b in the numerator. Hopefully that makes a little sense. Another thing, if this thing comes out negative, square root of negative isn't a real number. If I randomly generate a's, b's, and c's, half the time this is going to be negative. Okay, so there'd be no real number solution. Now, if what you have here is positive, then you do have a number for the square root other than 0. And when you add it to b, negative b, you get one result. When you subtract it from b, you get another result. Okay, I'm going to forget all that, at least I said it once. There's a formula. But try not to forget it. But when you're sorting stuff out and you're not totally familiar with it, you tend to forget anything except what do I do next? Okay, they're finer points and we'll talk about them again. So, but it's worth thinking about what I just said. There's a lot of content in those comments. Now, again, getting to what I do now, well, you identify A, B, and C, and you plug them into this formula. So can you do that? Can you identify what A is, what B is, and what C is, and then plug them into the formula and evaluate it? Okay, now, of course, you should do this with your own equation. Maybe you did. And if so, that's great, but it's really quite easy. And you're not going to have any trouble with it when Open Math asks you to do it. So we have x equals negative b. How do I identify b? It's what's in front of x. And what's in front of x is 9, so it's negative 9. Plus or minus the square root of b squared. Well, that's going to be 9 squared minus 4ac. What's a? It's negative 12. So that's 4 times negative 12 times 6. And then you divide over 2 times a, which is 2 times negative 12. Now, you just do the arithmetic. This is going to be negative 9 plus or minus the square root of 81. And then it's going to be minus 4 times negative 12 is negative 48. And 6 times that is negative 288. And this is negative 24. Well, that's negative 9 plus or minus. I'm going to skip a step. Negative 288 is 288. Does anybody use my equation to get 288 there? Use my equation and you didn't get 288. Well, there's something seriously wrong with your arithmetic, but let's see. Okay, don't say anything. We just 4 times 6 is 24, which is 2 times 12. 12 times 12 is 124. And double 144, I should have said. And double that is 288. So I'm still getting 288. Did I get the right numbers here? I got that. There's A, and there's C. There's A, and there's C. I don't know. I think I'm going to stick with what I got. With all due respect. And you know what? Oh, that's 369. I got all excited. I thought that might come out 361. So the square root would just be 19. But okay, that's over negative 24. Hope I've got room to complete this. Okay. So I'm going to write that as okay. Now notice I didn't write negative 24 down here because I'm doing a plus or minus on the 369. If I divide by 24, the plus and the minus are going to accommodate the minus here. Okay, so I don't really need to worry about the sign of this thing since I'm doing a plus and a minus anyway. And negative 9 over 24 is the same as 9 over 24. That reduces to 3/8. I can factor 9 out of 369. In other words, 369 is 9 times 41. So this is the square root of 9. Times the square root of 41 over 24. And of course, the square root of 9 is 3. Get ridiculous. Continue on. Let's demonstrate the arithmetic. Okay. Square root of 9 I replace with 3. And of course, then 3 into 24 is 12. So it reduces down to 1/8, right? Divide the 3 into 24, and we get the square root of 41 over 8. Now we've got a nice, neat expression we can plug in here and verify our solution. Now, you probably don't want to deal with all those fractions and squaring it and stuff like that. And you could easily make mistakes with squaring it and so forth. So it'd be kind of okay to do a decimal approximation there. Okay. The square root of 41 is like 6.4. So 6.4 over 8 is about 0.8. Okay. So now I can say this is about 3/8 plus 0.8 or 3/8 minus 0.8. Of course, 3/8 is 0.375. So we can go on with that. We can easily get two numbers. But what I'm illustrating here is the plus or minus means there are two solutions. One is with the plus, one is with the minus. Okay. And I think all that's visible on the board. Okay, well, probably put too much stuff in here. But we see that this is really quite simple. So as solutions, x equals 3/8 plus square root of 41 over 8. And x equals 3/8 minus the square root of 41 over 8. Okay. And we can approximate these. Approximately, that's like 0.375, so it's 1.2. Just going to round up. Very approximately 1.2 to negative 0.4. Okay, so what good is this? I just said, sometimes these equations come out of real world situations. And when they do, it's kind of important to be able to solve them. Of course, you can always go to Wolfram Math and type it in and get the solutions. But that doesn't build the kind of understanding you can build if you do it yourself. So once you know how to do it yourself and are firmly grounded, then it's kind of okay. Especially, if you're not trying to learn the mathematics, you already know it and you try to apply it. Well, I like to trust but verify. Trust Wolfram Math, but verify it yourself. Okay. So in an applied situation, of course, the numbers are probably not going to be this nice. And you really don't want to crunch those numbers. Although you can with a calculator or a computer. You don't want to crunch them by hand. They're too much. I wouldn't crunch them by hand. I'd approximate them and do it in my head. So it could be wrong and then correct it. Or so maybe something like it right. But there we are now. Graphs are a big thing in this course. So another way of stating the quadratic formula function y equals f of t equals at squared plus bt plus c. And of course, that's just the same as this, except I'm using t for the variable, and you use a variety of things for the variable. Often it's x, but quite often it's also t. And sometimes it's u, v, a, u, whatever. Probably don't want to use a. You get a triple A there. Okay. You don't want to call them unless you got a problem. Okay. I should say has a graph that passes through the x-axis. Okay, passes through these points. only these. Alex, see, I was typing it, I put a few more words around that, but there's the idea. Okay. That won't stand up in a court of mathematics, but it's close and everybody would know what I meant. Okay. So what does this tell us about the graph? Graph of negative 12t squared plus 9t plus 6. What can we determine about this graph from the quadratic formula? Well, one thing we can definitely determine is that it passes through 0 at approximately 1.2 and negative 0.4. Because that's where this expression is equal to 0. If this expression is equal to 0, well, it's only equal to 0 at these two values, because the quadratic formula will give you exactly the same numbers. Doesn't matter if I have t's here or x's. Okay, so this means that f of t is 0. F of t is 0 means that we're on the t-axis, because f of t is y. Okay, so that means we have zeros at negative 0.4. I'm going to change where I've labeled it because I don't want my graphs to go through my labels. Okay, so I'm just going to label the point negative 0.40 and (1.20). Those are approximate. Going to be a little to the left of this, a little to the right of that, I think. Okay, there's a graph. Okay, what else do we know about the graph? Well, these are the zeros. From the quadratic formula here and here. And now what's the probably the easiest point to find on this graph? What would I substitute for t? Find the easiest possible point. Okay, now this is important. The easiest number I could put in for t is 0, isn't it? So I put in 0, this is 0, this is 0, and f of t would be 6. Well, it's really easy to do that. I just put okay, put 0 in for t, I guess. 6. What do we call the point 0, 6? Okay, so I asked, what do we call the points we get when we substitute 0? Well, that's going to give us the point 0, 6, right? X is 0, y is 6. So I don't have a good place to label it because I didn't leave myself enough room. I have to cross my notes here, but my arrows. p equals 0, x is 6, so the y-intercept is 0, 6. Well, I'm going to put it about, let's put that point about here. I don't want to put it too high for reasons that become apparent in a minute. So that's the point, 0, 6. Now I've got 3 points in the graph. I can't draw a straight line through those 3 points. Straight line is fuel. Or as Captain Picard would say, futile. Anybody watch Star Trek in the 90s. Okay. No straight line is going to go through those 3 points. In a straight line that comes kind of close, might be about here, but close isn't going to get the graph. Okay. So my question then is, what shape do you think this graph might have? Okay, so intuitively, you know, we could try, well, cube function, no, that wouldn't work. You get 2 points with the same coordinates there, same x coordinates. It never really becomes horizontal except at that instant when it goes through the origin. And if it did go horizontal between here and here, it would go here. Okay. So it's not going to go through there. Now there are polynomials that go through those, but they have to go through another point. You know, we haven't done polynomials. Polynomials of degree greater than 2. But and you don't need to understand that now, you will very soon. Okay. But the squaring function, because we've got a t squared there, makes sense. Also, just from the shape of the function, and that's the way you answer the question. You're tracing this, and I've seen everybody kind of doing this, right? Okay. So a nice smooth parabola. These points might look like this. Okay. This suggests a transformed squaring function could fit. In fact, there's only one transformed squaring function that'll fit those 3 points. Okay. Okay, so only one transformed square function that fits. Exactly one. Through any 3 points that have different x coordinates, you can always fit a transformed squaring function. That's a big deal. Matter of fact, it's one of the biggest deals in the universe. Because of that, things tend to oscillate. And that's true at the quantum mechanical level. Now, I'm not going to develop quantum mechanics for you. I do that in 15 minutes, but now you'd have to know a lot. I'd have to think a little bit before I did it. Because I don't know that much quantum mechanics. I know how to do the simple harmonic oscillator, and that's all it takes. Okay. There's only one transformed squaring function that fits. That's what you need to focus on, need to understand. We can actually find that transformed squaring function. All we got to do is say, okay, ax squared or at squared plus bt plus c equals, or let's a times f of x minus h plus k. Expand that and fit to this, and we can figure out what h, k, and a are. Okay. Yeah, no, I'm just saying that. I'm not going to do it for you right now. So the graph would be a parabola. Okay, well, we've got 3 points. I'm running out of board space to make notes. I'm going to ask you to do one thing. This parabola is symmetric about a line. We call that line the axis of symmetry. If the parabola is symmetric about this line, that means any point on this side is just a reflection of the corresponding point on this side. Okay? So I'm just going to ask you to think about it for a minute. What's the x value for this axis of symmetry? X equals what on this axis? Okay, now we'll answer the question, but I'm going to redraw the graph because I'm out of space. Put notes on. I don't want a kind of an uncluttered graph here so I can actually talk about it. So I don't know how well I drew that. I don't know how symmetric it really is, but it's supposed to be symmetric. It really isn't too bad. But I mean, that's the flaws in it, as always. Okay, so what's the x value here? Well, one of you said it. It's got to be halfway between these 2 points, and it's going to be symmetric, right? So the axis of symmetry has to be halfway between the zeros, since they're at the same level, same y value. Okay, this has to be a mirror image of this. Yeah, I've still got the room on the board. Okay, even if I didn't draw it quite right, it's hard to draw these things. At least I find it hard. I could be more careful and do a better job. Okay, close enough. So what's the value of x if it's halfway between this point and this point? See if you can tell me that. Oh, come on. Okay. Halfway between -0.4. Now somebody couldn't see the decimal points. I made it a lot bigger. Made that a little bigger. Make sure we see that's a 4, not a 9 or something even worse. Okay, halfway. I got it. Fundamental fact of the number line for any numbers, it's really important to be able to visualize this. Halfway between any 2 numbers is the average, what we usually call the average of those 2 numbers. There are other types of averages, but when we talk about the average of 2 numbers, we're really talking about what you get when you add them and divide by 2, right? Okay. So now x is 0.4 on this axis of symmetry. Any question on that? Okay, so now remember, this is the function. F of t equals negative 12t squared plus 9t plus 6. So what are the coordinates of this point right there on the axis of symmetry, which of course is the peak of this function? So, I asked the question, what are the coordinates of this point? And I got an answer, wasn't a great answer, but you're thinking, okay. And it's okay, 0.4. Now, if you mean 0.4, the number 0.4, well, that's 0.4 here, and that could be helpful. But 0.4, which I think is what was intended, I didn't look at the paper, would be a point about here, 0.4. Here's 0.6, 0.4. Well, let's see, halfway 0.3, 0.01 would be about here. 0.4 is down here close to the origin. And I hate to break it to you, but I'm sorry. It's not this point. Okay. Now, how are you going to figure out this point? Well, you know the x coordinate is 0.4, or the t coordinate, I should say t, since we're in context where this is the t-axis instead of the x-axis, but same thing. Okay. How are you going to figure out the coordinates of that point? Okay, I just asked a question here. What do you think the coordinates are if you just look at the numbers? What do we estimate the coordinates to be so that when we finally get to the calculating it, we'll have something to compare it with, okay? What do you think the coordinates are? Most of the estimates I got were like 0.7, 0.8, okay? Or 0.7, 0.8, not 0.7, 0.8. So if I project this over here, if this is 6, 7 or 8 looks pretty good here, right? Okay. So let's just say, I'm going to do an honest estimate. I'm going to kind of divide this and then subdivide that into two pieces. Then I'll draw pieces here. I don't know, again. My guess, based on my graph, right in line with yours, okay, is and y looks like it's about 8.7. Okay, it's not quite 9. I think it's a little over 8, but that's just based on the way I drew the silly graph, which wasn't all that great. It's a little lopsided, a little lower on this side, but didn't do a good job. Okay, so we can't be very confident in my estimate. So if I got a better estimate than everybody else did, it's only dumb luck. Okay, because your estimates were perfectly good. Okay, well, how can we actually calculate what the coordinate has to be? What can we do to calculate the x coordinate or the y coordinate of the vertex? Okay, now this is a big deal, and it took us a while to get here because nobody really wanted to use the fact that we have a formula for this function. And the formula led us to this point, and this point, right? Don't we think maybe it would lead us to this point? I'm not trying to shame anybody. This is always a sticking point. I wanted to bring it out really explicitly. And you want to hang on to the ideas we're getting here because they apply to several important aspects of this course and particularly the pre-calculus course. Okay, they'll do you a lot of good. You'll understand much better if you understand what we're talking about. So the point is now, y equals f of 0.4 because y equals f of t. I didn't write y equals up here, but I could have. And you usually see y equals f, the graph of y equals f of t. Or you want something else, p equals f of t. Then we try to find the value of p for the profit of an investment, okay? Or of a company. And that's exactly a model that we're going to talk about, okay? If T is how much you charge for something, then Y might be how much your profit is. And you want to find your maximum profit. Now, from some simple assumptions, you can easily get a quadratic model. And then you want to find where the quadratic model peaks. And that tells you what to charge to maximize your profit. If you're just selling, if this is in dollars, you charge 40 cents. And what's your profit going to be? I mean, of course, your profit is in billions of dollars. Okay. Because you're selling a really important part for anything that uses chips. Selling 40 cents a piece is a multi-billion-dollar industry. Okay. Okay, anyhow, y equals f of 0.4. How do you calculate f of 0.4? You replace t with 0.4. And then you calculate it. Now, right here in front of your eyes, I'm going to mess up the calculation. Okay. 9 times 0.4 is 3.6. 3.6 and 6 is 9. Now, that's a little higher than what we estimated. But we have to then subtract 12 times t squared. And we're going to come closer to your estimates than we are to mine. Okay, because t squared is 0.16 and 12 times 1.6 is 1.92, if I got my numbers right. And we subtract 1.92 from 6, and we get 7. Oh, come on. 7.68. And look at how much better your estimates are than mine. Everybody estimated between 7 and 8. This is almost halfway between 7 and 8. Okay. I'm going to have to start an industry and hire you people. Okay, well. So coordinates are, if I did the arithmetic right and you do your arithmetic, but it's going to come out pretty close to that. It's not quite right. Pretty sure it's right. Reasonably sure it's right. So somehow you all just knew that this is going to be a multi-billion-dollar industry, and that's how you're going to maximize the profit. Just incredible business sense. Okay. Well, maybe. Hopefully. There we have it. Now, big deal here. Okay, 1.2. 0 and negative 0.40. Halfway between negative b over 2a plus the square root of b squared minus 4ac over 2a. And negative b minus the square root of b squared minus 4ac over 2a, because this is how we got the 1.2. Actually, it's how we got the point negative 0.4 because A is negative, okay? And this is how we got the 1.2, doesn't matter. These two things are how we got the negative 0.4 and the 1.2. Now, what's halfway between this and this? What's halfway between negative 3/8 plus 0.8 and negative 3/8 minus 0.8? What's halfway between 14 inches to the left of my nose and 14 inches to the right of my nose? My nose. What's halfway between negative 3/8 plus 0.8 and negative 3/8 minus 0.8? Negative 3/8. And negative 3/8 is negative 3.2. It's not negative 3/8. It's 3/8. Okay, approximately 0.4. Halfway between this and this, the two things you get from the quadratic formula. Well, by similar reasoning, what's halfway between negative b over 2a plus this thing and negative b over 2a minus this thing? Give you a chance to say, but we're out of time, so we'll have to do this quickly. Okay, got a good answer very quickly because we're a little over time. We want to get this done so people can get up, move around between classes so you don't go nuts in the next class, which is my next class. Okay, so negative b over 2a is here. Negative b over 2a plus that thing. Negative b over 2a minus that thing. Right? Those are the zeros. Halfway between the zeros, my nose, right? Negative b over 2a. So halfway between these things is negative b over 2a. So that we now have a penny function for this one in particular, the zeros here and here in the line x equals negative b over 2a. That's always our axis of symmetry. Big deal. And your life in pre-calculus will be so much easier over the next couple of weeks if you know that. Then you won't have to memorize a bunch of formulas, although it's good to memorize them. You'll understand what they mean. Okay. Now we've covered quite a bit of stuff here. I didn't know that's what we're going to cover. We have to go by your lead, but you led very nicely. Okay, that was a really good job.